So I thought we'd have a look at another way of doing bond enthalpy calculation. Exactly the same question. And then you can see which method you prefer. So again, for any bond enthalpy calculations, I think it's worthwhile doing the displayed formulas for the reactants and products. So N2H4, well, we're told it's got a nitrogen-nitrogen bond, and then we'll add 4 hydrogens to that. Then react that with oxygen, oxygen double bond, gives nitrogen, which is a nitrogen triple bond, and water is H2O, and we have 2 of them. So when we're given bond enthalpies, bond enthalpy is the energy required to break a mole of bonds and turn them into gaseous atoms. So we can break the reactant bonds and we can break the product bonds and turn them into gaseous atoms. And then we just work out the energy required to break those bonds of the reactants and products. So for nitrogen, we've got a nitrogen-nitrogen bond, and that's what we're trying to calculate. And then we've got 4 nitrogen-hydrogen bonds, which is 4 times 388. And an oxygen double bond, which is 498. And if we add all that up, 4 times 388 plus 498 is 2050. On this arrow, we've got 2050 plus x. So I could write that in a different colour. On this arrow, so that's 2050 plus x in total. And therefore, we'll have a look breaking the bonds of the products now. So we've got a nitrogen bond and 1, 2 times 2, 4 OH bonds. And 1 nitrogen triple bond is 944. 4 OHs is 4 times 463. Then add them together. Is 2796. So that the arrow. And on the reaction arrow, we're told the enthalpy change is minus 583 kilojoules per mole. And then because we've drawn this as a cycle, we can see for the reaction, where we're going from reactants to products, we're going with the reactant arrow and against product arrow. Enthalpy change for the reaction equal to 2050 plus X, and then we're going against product arrow, so we change the sign, that will be minus 2,796. So if we rearrange that for X, we could leave X on this side, take the other numbers the other side, we get minus 583, minus 2,050, and plus 2,796, and therefore X, and therefore our nitrogen bond in hydrazine, which is used as rocket fuel, minus 583, minus 2,050, and add 2,796 is plus 163 kilojoules per mole. And we could change the X to a nitrogen bond. Okay, so this is another way of doing bond enthalpy calculations. If you're okay with and familiar with doing Hess's law cycles using enthalpies of formation and combustion.